Okay, so yesterday I took some time and fixed some of the bugs because yesterday was not very great. We ran into a lot of problems, right? So I added this skip movement to Boolean. I fixed our lowest milestone stack order. So that's working right. So now we don't have that bug when we pick up from more than a 5 stack. We can actually dump our stones. So I fixed that, and then when we added this line here, we were putting this was to sweetie. This was to switch our movement event into movement event 3 if we only had one occupant in our hand. But this was having the effect of actually changing us to a movement event 3 whenever we had an occupant in our hand, one occupant in our hand in a movement event 2, which wasn't the case. We only wanted that if we were initially moving into a movement event 2 with one occupant. So we added this Boolean here to only do that moving into movement event 2, and then otherwise we can have one in our hand and still be in a movement event 2 because we haven't locked in our stones yet. So I fixed that as well. Then it looks like we changed some of this. Okay, yeah, then the other thing we changed was we swapped the order of our we swapped the order of these two if statements, which was previously preventing us from dropping a stone in an empty grid. So all of those things fixed maybe 3 or 4 bugs from yesterday that was just driving me crazy. But now that we're done with that, we can continue to move on with our developing our capstone crushing logic. So let's go ahead and continue that. Now there still is a bug, and I'll show you what that is. And that's if we have a bunch of stones. If we have a bunch of stones moving into a grid of a 14 grid, we need to make it illegal when it currently isn't. So check this out. If we pick up, let's say this many stones, and we're moving to the left, see how there's a 14 stack over here? So if we pick up all of our stones here and only dump one there, pressing enter shouldn't lock in this grid because we're at a 14 stack, and then dumping one in there will make us crash. So we'll have to fix that, but I'm not going to fix that just yet. I'm going to work on our capstone crush logic first, and then we'll go back and fix that. Because we only got to a corner case in our capstone crush logic yesterday before we ran into all those problems. But we fixed we fixed those problems, thank God. And then yep. So let's go ahead and continue with our edge case. Now, if we take a look at what we were doing with our standing stone crush, we're making a standing stone grid a legal move if the mouse stone occupants is only one and our mouse stone control is a capstone. So we only have one. If we only have one member in our hand and at the capstone, then we can crush an orthogonal standing stone. That doesn't change it into a lay stone yet, but we'll get to it. We're just making the legal moves first. So for our edge cases, we need our top edge. So our top edge would be if our movement origin row is equal to 1, that's the top row, and our movement origin column does not equal a 1, and our movement origin column does not equal a 5. then it's a top edge. Now we need to do right edge, which would be if our movement origin column is a right edge would be a 5. Our column is 5, and our movement origin row does not equal a 1 or a 5. And not or, but and. It can't be equal to a 1, and it can't be equal to a 5. So that would be a right edge. Now we would need a bottom edge. Bottom edge would be a movement origin row equal to 5. And our movement origin column would have to not be equal to 1, and it would also have to not be equal to 5. For a bottom row. And then our left edge, which would be if our movement column is equal to 1. Yeah. If our movement column is 1 and our movement row, movement origin row would not be equal to 1, and our movement origin row would not be equal to 5, then that would be a left edge. So what we need to do here is the same thing here, where we say we need to check all orthogonal spots in the edge case, which will be 3 instead of just the 2 in our corner cases. So we need to check 3 different orthogonal spaces, and if that stone control is equal to a standing stone, then go ahead and switch us to a legal move. So that's all we got to do. But we got to write 3 cases for each edge. So with top edge, let's just write these in real quick. We need to do, if it's a top edge, we need to check left, we need to check down, and we need to check right. If it's a right edge, we need to check top, we need to check left. I'm going to say up, we need to check left, and we need to check down. If it's a bottom edge, we need to check left, we need to check up, and we need to check right. And then if it's a left edge, we need to check up, we need to check right, and we need to check down. So those are the grids we need to index. Now, we can't hard code in the number indices here. We'd have to do the logic based on our row. So let's just give us a template of movement origin row, movement origin column, and we know we at least start with this. So movement column, and we know we're checking for a stone control to be equal to a standing stone. So this is kind of our template for each. Come on. Here we go. So this is our template that I'm going to copy. Now, we need 3 cases where we do something. And when we do something, this is wrong. I need a period here. When we check this, we're gonna be placing legal move true of whatever grid. So we need left. So left would be a column -1. So column -1 would be left. Down would be a row +1. I'm just realizing that this is wrong because a capstone doesn't a capstone could happen in any movement event. So we probably need to ultimately put this into a function. Goddamn. Because right now we're only checking for a capstone crush in a movement event 3, but we could technically do a capstone crush in a movement event 4, 5, 6, or 7. If the only thing is in our hand is a capstone. I'm not going to worry about that just yet. We got to build it out anyway, then we got to put it in a function, and then we can come back and minimize it, because we need to add this functionality for the other movement events. So yeah, we will need to turn this into a function eventually. Not going to worry about that just yet. But yeah, we do want this. This wouldn't be movement origin row, it would be whatever our parameter is that we would pass in at every given movement event, which, depending on the movement event, it depends on which switch the parameter getting passed in, because we're trying to check the stone that you clicked on, the grid that you clicked on. But we also need to force a drop of stones if the next grid is going to be 14 occupants. So, wow, it's a lot of work. It's a lot of work. Yeah. Okay, let's just get this going. Let's just get it working here. We can worry about functionalizing it later. Okay, we need the right of us, which would be a column +1. Now, inside these brackets, we need to check, or we need to assign if they are in fact controlled by a standing stone, then we're going to assign a legal move to be equal to true. Okay. Right edge. Okay, this is sort of our template. I'm going to go ahead and build out all the rest of the cases. We know we need 3 different cases for each edge case. Just need to make sure we make it right before we move on. So we've got our top edge. Let's do our right edge. And our right edge needs the one above us, which would be a row -1. And then that is the index that we would need to change to true. So put it right here. This legal move gets true. Now we need our left edge, which would be a column -1, same row. And then that's the index we need to modify. So we'll say grid at this thing dot legal move true. Then we need down, which would be a row +1. And then this is what we need to modify. Donk. Okay. Right edge done. Let's do bottom edge. We need our left side, which would be a column -1. Okay, then we need above us, which would be a row -1. And we would need the right side of us, which would be a column +1. Okay, then we need, for our left edge, we're going to be saying we need an up above us, right and down. So above us would be a row -1. To the right of us would be a column +1. Down would be a row +1. And then we're done with our edge cases, and we need to move on to our middle cases. So our middle case is determined whether or not our movement origin row, if our movement origin row does not equal 1, and movement origin row does not equal 5, and our movement origin column does not equal 1, and our movement origin column does not equal 5. Then we know we're a middle case. That means we need to check every orthogonal space around us. So we need 4 cases. Here's our default. We need to check, below us, left of us, up of us, right of us, down of us, all directions. 4 direction. Okay, so I guess start with above us. It'd be a row -1. To the right of us would be a column +1. Beneath us would be a row +1. And left of us would be a column -1. So if we in fact did this right, we should be able to crush a standing stone with a capstone in a movement event 3 in any space we are at. So let's give it a shot. Let's try a middle case. So here we are. We have access to move in any space because a capstone can move in any space as long as it isn't a capstone, which we should probably check. I'm just going to move this here, and I'm going to say there's a capstone here. Now it's looking like that's working. We can't move on a capstone, but we could crush a standing stone here. Nice. So we haven't flattened it yet into a laystone, but we'll get to that. Let's try an edge case and make sure that's working. Yep. Cool. So it's looking like we've done it. And then we can't go into the 14 stack, which is why this one's not a legal move. So that's making sense. Cool. So we'll need to put this in a function with a given movement origin, and it's not movement origin, it's going to be like whatever parameter we put in, and whatever parameter that gets passed in needs to be the space that we're dumping our capstone into. So in this case, if it's a movement event 3, so yeah, we say right here, right off the bat, we say in movement event 3, make any legal move true if it's a stone control of standing stone. We have a capstone in our hand, and only a capstone in our hand. And then we say, yeah, okay, this is corner cases. Okay. So yeah, this is just all of this line, all of these lines are turning a standing stone into a legal move if we only have a capstone in our hand. And we'll need to do that on every movement event. So we need to pass in not a movement of origin row, but we need to pass in whatever our current grid that we're coming from is, which at a movement event 3 is a movement origin. But if we're in a movement event 4, we would need to have our first movement origin. If we're in movement event 5, we need our second movement origin, both row and column. So we need to kind of factor out this so we can make it into a function so we can do all of these lines of code every single movement event, so that we can ultimately crush a capstone, crush a standing stone with a capstone in any movement event, which should be possible. So we've got it working. I'm not so energized to turn this into a function today. I've got stuff to do very shortly, so I think I'm going to call it an early day. But we've got it working. We just need to update our movement origin row to be a grid that we're coming from. So a row that our capstone's coming from instead of locked in at a movement origin row, which is only true for a movement event 3. So tomorrow we will get to that, so that we can implement capstone crush. And then once we get the legal moves on a capstone crush, we need to check for the actual placement. And if we place a capstone on a standing stone, we need to actually change the stone type of that standing stone to be a lay stone, same color. And that'll be under here, under our mouse pressed. So if we press in a legal move, we need to ask, hey, are we having only one occupant in our hand, and that only occupant is a stone control of a capstone, and is the grid at our mouse grid a stone control of a standing stone? If so, once this is pressed, we need to also, over here we would also say, by the way, that standing stone type is now a stone type of lay stone, so that we can actually crush it. So we'll also have to add that for every other movement event, so we might want to make that a little function as well, saying, is this a capstone crush based on the amount of occupants in our hand and the stone type of the grid that we clicked on. And that'll be a little function by itself. So we'll have two new functions for our capstone crush, implement it into each movement event after our second. So we'll get to that. I just don't have the energy to do it all right now. But let's go ahead and we'll add to the staging area our changes, so we can say finished adding capstone crush legal moves. Need to factor into a function, which we'll be doing next episode. Then we'll worry about that other bug. But for now, that's good. And we've got another day of programming. Okay, so I will see you guys tomorrow and we'll get some more functions written.